Hello and welcome to our biological reactor build video. You've shown a personal interest in our work by signing up for this video, and I personally want to thank you for that. This video places an emphasis on the construction of the biological reactor and less on entertainment. So let's just get started. I'm recording this from my desk again, and outside my window is a busy street, so there may be a loud vehicle from time to time. Please forgive the background noise. As we constructed the 4 tubes of our current system, we made adjustments and improvements along the way. So you'll see variances in the 4 different tubes that we have on this wall. I'm going to use this tube as our model for this video. First, let's go through the inventory of parts you'll need to complete the tube that we built. You will need 2 4-inch end caps for the top and bottom of the digestion tube. 3 2-foot-long 4-inch tubes for the body of the digestion tube. 2 4-inch PVC pipes with a 3/4-inch T-socket. You'll need some clear bottles. It was very difficult for me to find plexiglass out here, and I found that a clear bottle with a smooth surface did the job just fine. I actually used a couple of Listerine bottles, and I used an Evian water bottle, and those worked perfectly. You'll need stainless steel screws. 1 3/4-inch male and female threaded socket. 1 1-inch male and female threaded socket. 1 1-inch by 9-inch perforated pipe filter. I'll give more details on this filter later in the video. 3 3/4-inch by 9-inch perforated pipe filters. I'll give more details on these filters later in the video as well. 1 1-inch end cap. 3 3/4-inch end caps. 1 oxygen one-way valve. 1 oxygen air stone. 4 3/4 elbow sockets. 1 1-inch elbow socket. 1 3/4-inch socket threaded. 1 3/4-inch shutoff valve. 1 1-inch shutoff valve. 1 3/4-inch check valve, also known as a foot valve. 20,000 6mm polypropylene beads. Now your beads can be any size. I wouldn't recommend anything over 6 millimeters. And in fact, a lot of floating bead filters out there use beads that are smaller than 6 millimeters. I chose 6 millimeter because that's what was available out here. And I had to special order these from China. When we get to that step, I'll give you more details about how I obtained my polypropylene beads. 1 tube of silicone sealant. And then last, you'll need PVC glue. For the purposes of this tutorial, I'm not going to teach you or demonstrate how to glue the pipes together. There are a lot of videos out there on YouTube that can teach this. For the purpose of just expediting this video, I'm going to skip that step. First, we're going to cut the viewing windows into the 2-foot pipes. So take one of your 2-foot pipes, measure to the middle of it, then take a 2.5-inch hole saw and proceed to cut. When you cut out with the hole saw, you're going to end up with a little disc from the center of that. Hang on to that disc because we'll need that later in the assembly. Now the next step is pretty obvious. You want to just cut a piece of plastic that is slightly larger than the hole that you've made for your viewing port. I did not pre-drill holes in the plastic because I purchased stainless steel screws that are self-tapping. But I did not glue before I ran the screws through the plastic because I knew some of the plastic would get pushed to the side and cause air gaps between the plastic seal and the pipe itself. So I ran my screws in just to make the holes and then removed them. Then I scraped the plastic clean around the pipe and the section of the bottle that I cut out. Then I applied silicone sealant around all the screw holes and then reattached the plastic with the stainless steel screws. Two of the viewing ports are placed at the center of the top and middle pipe, but the bottom pipe, the viewing port, is located 6 inches from the bottom. This is to allow viewing of the purge filter and to make room for the air stone that is placed at the center of the bottom pipe. Now that we have the viewing ports complete on the main pipes, let's set up and assemble the 4-inch to 3/4-inch T-sockets. The T-sockets are designed to allow the transfer of water and liquids while holding back the polypropylene beads to their assigned tube. The T-pipe simply consists of a 3/4-inch pipe filter with a 3/4-inch cap. Our 3/4-inch PVC pipe has a solid space of 3/4 inches at the front for the 3/4-inch cap to fasten to. Then we've drilled holes that are as large as possible without allowing the beads to pass through. The field of holes runs 3 inches long. The entire PVC pipe is 9 inches long. The pipe filter passes through the 3/4-inch T-socket and is glued in place. However, the T-socket from the manufacturer is not designed to allow the 3/4-inch pipe to pass through. If you look closely, you can see a stop ridge at the edge of the pipe hole. You want to file that down so that it's smooth, or a Dremel or some other type of grinding device. Once your 3/4-inch T-socket is ground down smooth, simply pass the pipe through, attach the 3/4-inch end cap, and glue in place with PVC glue. Now let's begin assembly of the end caps. I'm referring to the top end cap as the transfer end. I'm referring to the bottom cap as the purge end. Without gluing, place the end cap on the end of one of the 2 feet lengths of 4-inch PVC pipe. Using an 1.25-inch hole saw, cut a hole centered on the end cap and then knock off the end cap. Now the 1-inch diameter pipe filter I'm referring to as the purge filter when it's attached to the unit. The entire pipe is 9 inches long, and I've left 1 inch on each end undrilled so that it can be attached to the end cap and to the 1-inch socket. Using PVC glue, attach the 1-inch socket through the end cap. Then attach the 1-inch purge filter with the 1-inch cap attached. Glue in place with PVC glue. Now I used silicone to attach the end caps to the 2-foot pipes, and I did this because in the future I may want to access the inside of the tube, and I wouldn't be able to do that if I used PVC glue. By using silicone, I can knock the end caps off later with a hammer. Now that you've completed the purge end of the filter, you'll need to do the transfer end of the filter. Remember that the transfer end of the filter uses all 3/4-inch sizes, so repeat the same steps as you did for the purge filter on the transfer side of the filter, but make all measurements for the 3/4-inch size sockets and pipes. Now I'm going to make the dissolved oxygen port for the air stone. As you can see on my digestion tubes, I made 2 ports, one on each side. This turned out to be overkill, so I ended up just using one side. So I used a 1-inch hole saw to make an opening for the air stone halfway up the bottom tube. Now remember those discs I told you to keep? Here's where we will use those. I passed the air hose through the disc and attached the air stone to the air hose. Then I used hot glue to fasten the air stone to the disc. Next, I applied silicone around the outside of the 1-inch hole we cut. Then I placed the air stone in the hole and seated the disc on the silicone adhesive. So we're almost ready to assemble and close up the digestion tube. But before we seal it shut, we must add the polypropylene beads. Polypropylene is a food-grade plastic that is very widely used in grocery store packaging. In fact, you probably have polypropylene packaging in your refrigerator right now. The beads I ordered have a life expectancy of 400 years. They have an air bubble inside to keep them buoyant. I ordered mine from Alibaba. Because they are a commissioned product, I paid a high price. I'm sure you can find polypropylene or other food-grade floating plastics for less, but this is what I had to work with in my location. As stated earlier in the video, I'm not going to demonstrate the gluing and assembly of the tubes. Just make sure your beads are inserted before you close it up, and be sure you are using PVC glue on the connections, with the exception of using silicone adhesive on the purge and transfer caps. The last step is to add an aspirating valve and interconnect your pipes. Here are some final thoughts about our biological reactor working prototype. First, understand we way overbuilt our system because it's actually a working laboratory and we needed proper scale for future projects. A single tube will well meet the needs of most home aquaponic gardeners. Second, the system produced so much nitrate, potassium, and phosphorus that we now realize we could have completed a successful garden with a single chicken producing manure only during the overnight hours. Third, a microburst purge once in the morning and once in the evening was enough to clear the waste and keep the digesters happy. A twice-monthly total purge of the entire tubes kept the beads cleared and healthy. Fourth, our design implies we dumped wastewater on the ground. As a more holistic, environmentally responsible practice, outside of recording, we did filter the manure with a cheesecloth sack and captured the filtered effluent. Then we reintroduced the strained chicken water into the catchments. I sincerely hope this video was helpful to you. I plan to make more videos in the future. Please feel free to contact us at email address jj@chickenaquaponics.com with questions or comments. My name is JJ, and I wish you the best of luck with all your hydroponic endeavors.